Welcome to another Greek developer tutorial. In this video, we'll go through the entire process of generating, collecting, and visualizing metrics, starting from a C# web API, adding OpenTelemetry, scraping data with Prometheus, and finally building a live dashboard in Grafana, an end-to-end journey from code to insights. Before we jump into coding, let's review the final solution. We have a .NET Web API application, which we instrument with OpenTelemetry to export its metrics at the /metrics endpoint. Then we have Prometheus that collects these metrics via HTTP calls and stores them in its internal database. Finally, Grafana that uses PromQL, the Prometheus query language, to retrieve and transform these metrics in order to visualize them. All right, let's start by creating a brand new .NET project together. This gives us a fresh starting point that we can immediately build and run. Now, let's edit app settings and add a configuration for the default port. By doing this, the application will always start on the same port, unless we explicitly change it. Once we've saved the change, we're ready to run the app. With the app running, let's switch to a new terminal window and verify that the app responds as expected. Time to add the code that will enable OpenTelemetry's metrics to our app. First, we will add the required package references to our project. Then we will edit program.cs to add the required using statements, add the required services to the dependency injection code, and set up the application's ASP.NET pipeline. For OpenTelemetry to work, we need to add our application as a service using the resource builder, and to set up the metrics builder with the instrumentation for ASP.NET and with the Prometheus exporter. Finally, we must map the Prometheus scraping endpoint. At this endpoint, the Prometheus exporter will make the metrics available. After all this changes, let's run again our application and test the Prometheus endpoint to see if it returns the application's metrics. Since the exporter works, we are ready to move to the next step of this tutorial on how to visualize them. But before that, let's add an artificial, random delay to each HTTP call to simulate an actual workload. Let's run the application one more time, switch to a new terminal, make a couple of calls on the weather forecast endpoint, and view our metrics. Before moving on with the infrastructure setup, we will run a quick one-liner to call repeatedly the weather forecast endpoint to generate metrics. At this point, our application is generating metrics and exposing them at a Prometheus endpoint. We need to set up Prometheus to read or scrape, as it's the official terminology, these metrics. Since we have already downloaded the latest version of Prometheus, we will unzip it and rename the output folder to Prometheus for simplicity. The next step is to edit Prometheus configuration file and add our application as a target for metrics collection. We will also add a custom label to the metrics to be able to differentiate them among other metrics. Keep in your mind that on a typical production setup, a single Prometheus cluster can scrape hundreds or even thousands of application instances. Now, let's start Prometheus and open its UI to confirm that our application is scraped for metrics. The default scraping period is 15 seconds, so we might need to wait a bit before our target is marked as being up and running. As we can see in the UI, our application is present on the targets. It is healthy, at least as far as Prometheus is concerned, and it is scraped regularly. Let's continue now with setting our visualization platform, Grafana. Again, we have already downloaded the latest version, so we need to extract it and rename the output folder for simplicity. Since this is a testing installation, we will configure Grafana to allow anonymous admin access. To do this, we will add the appropriate settings to the custom settings file. Finally, we are ready to launch Grafana and open its UI. Since we have a bit of work to do inside Grafana to build the metric visualizations. After we validate that Grafana is loading, we will switch over to our browser. Before accessing our metrics, we must set up a connection with Prometheus. To do so, we select Connections from the navigation menu, then Data Sources, and finally add Data Source. From the list of available data source types, we select Prometheus and then type localhost 9090 on Prometheus server URL text box. Finally, we scroll to the end of the page and click the Save and Test button. Going back to data sources, we can see that a Prometheus data source is now available. In Grafana, individual visualizations are grouped in a container page called Dashboard. So let's create one by selecting Dashboards from the navigation menu and then clicking on the Create Dashboard button. Now is a good time to change the time range to return data for the last hour. Let's add our first visualization by selecting Add Visualization from the top menu. In the View Visualization window, there are three main areas. On the top, there is a visualization preview that will show our visualization as we create it. On the right side of the screen, there are the visualization properties which control the appearance of our visualization. And on the bottom, there is the Queries panel, in which we will add and edit the queries that load the visualization's data. Now let's set the title of the visualization to HTTP request rate and the minimum value of the y-axis to 0. Then we will jump over to the query editor, switch it to code mode, type our first query, HTTP server request duration, seconds count, and hit the Run Queries button. This query returns the total request count, so we will add the rate function to get the request rate per second. As a last touch, we will change the legend mode to custom and set it to HTTP route. With this final tweak, our visualization is ready and we can return to the dashboard. We will create 3 additional visualizations, one with the total duration of the requests, one with the duration of the requests per endpoint, and one with the currently active requests. When it comes to duration metrics, it is impractical to record the duration of each request. OpenTelemetry uses histogram buckets to track the amount of requests that are completed in specific duration slots. In order to properly visualize these histogram buckets, we need to apply the histogram function as it is suggested on the query editor. By applying the suggestion, we get a graph with the duration of the 95th percentile. This means that 95% of the requests are completed in less or equal time than the graph indicates. Let's add another query to display the 50th percentile to see the difference. As you can see, 50% of the requests are completed faster than half a second, and 95% are completed faster than a second. This is reasonable since we added a delay with a random duration uniformly distributed between 0 and 1 seconds. Let's jump back to the dashboard and quickly add the next 2 visualizations. Obviously, Grafana is much more complicated than this, and we learned only the bare minimum in this tutorial. We will further explore Grafana in depth in an upcoming video in which we will discuss how to get custom metrics, how to create useful and immersive visualizations, and how to set up alerts to be notified before your users notice any issues. If you liked the video and you don't want to miss the next ones, please like and subscribe. So now you know how you can add metrics to your applications and how to create a basic dashboard. Thank you for watching and see you on the next one.